Algebra and functions using operations such as addition, subtraction, multiplication, division to create new functions is pretty familiar to us because we're already familiar with these operations. But in the world of functions, there's another operation that we don't see very often, and we don't see it in the real numbers, and that's composition of functions. And I'm going to show you some examples on how this works. Now the idea here is I like to use this illustration here. So pretend that this is the domain of a function. So in other words, you pick an input that I'll call x. You plug it in that function, we'll call it f, and you end up with something over here. This is my f of x output, okay, so my domain and my range. So you take that function, but maybe I want to also consider the idea of taking something over here that gets mapped over to this third set through another function that I call g. Alright, so here's my domain of g, and here's where it ends up. And so what I'm doing here is now mapping, that's the input I want to pick. So the input that I started with was x. F took it over to this new output I call f of x. But now for the g function, I want my input to be f of x. So when I map that over here, what is this thing? Well, that was the g function, but you plugged in as your input f of x. And so what we're going to do here is maybe I can, instead of going through these three processes, maybe I can start with x and get mapped all the way over to that output. How would I do that? Okay, so I'm going to create a new function that when I plug in x, it gets mapped into whatever you get from g once you plug f into g. And this is what we mean by g composed with f of x. And that's composition of functions. So as an example of composition of functions, here we want to find f composed of g of 3. And for part A, we have f of x equals x squared minus 3, and g of x equals the square root of x. So I want to find f composed of g of x. That means I take the f function, and as its input, I put g of x. So here, when I had f of x is defined as x squared minus 3, that means every time I see an x, I replace that with g of x. So it's g of x squared minus 3. So in this case, that's the square root of x squared minus 3. And the square root of x squared is x minus 3. So if I plug in the value of 3 into this new function, right, because x minus 3 is the function that I got when I composed x squared minus 3 with the square root of x, I get 3 minus 3, which is 0. Okay, so that means when I plug in 3 into this function, the output is 0. Alright, now for part B, we don't have the actual algebraic expressions. I don't know what f of x and g of x are. All I know that is if I plug in negative 5 into f, I get 2. And when I plug in 3 into g, I get negative 5. So how can I use that to find f composed of g of 3? Well, remember that that means that I take the f function and plug in as an input g of 3, whatever g of 3 is. And actually, I do know what g of 3 is. We set it up here. So that's going to be g of 3 is negative 5, so that means I need to find f of negative 5. And actually, I know what f of negative 5 is as well. So f composed of g at 3 gives you the output of 2. I hope the ideas of composition of functions make sense. I hope you feel comfortable with it. If you don't, that's okay. Let me know. I'll be glad to help. And thanks for watching.